Kia ora, I'm Murph. I'm the scientist and a lecturer here at the BHU, and today we're planting potatoes as part of an IPM, Integrated Pest Management Trial. So Harry's out there currently planting these potatoes. This is quite a small area we're planting. It's only about 40 metres long, and we've got about 5 beds we're going to plant. So instead of getting a machine, which is just a lot of work to go and borrow off somebody, we're planting by hand. What we've done is we've marked out the rows where the potatoes need to go by using the rigid tines on our tractor. So here's the rigid tines on the back of the tractor. For those enthusiasts, this is an old Ransom's frame. We've got 3 legs because that's what we're using for ripping. So instead of taking the centre leg out, so we just have the 2 lines, we're just ignoring the middle line at the moment. So this work's being undertaken for Dr. Peter Willem Hendricks at Lincoln University. He's working in with Potatoes New Zealand, who are bringing in Dr. Paul Horn from Australia, who's an expert in integrated pest management, IPM. He's by training an entomologist. And the issue we have here is in New Zealand that back in about 2005, we had a new pest arrive, tomato potato psyllid, which, as its name suggests, attacks potatoes and tomatoes, but it actually attacks everything in the Solanaceae family, the potato family. So tomatoes we've already said, but things like peppers. It comes from South America, so its native range is South America. Its native range is actually, South America. And one of its natural hosts is the boxthorn plant, which I didn't realise was actually part of the Solanaceae family, and boxthorn's an introduced species here. It also hosts on our native poru, often called the tree tomato in English, and that's also a Solanaceae. So it's very interesting that this insect has arrived, which has never been evolutionarily associated with poru, and it's quite happily hosted on it. The issue with psyllid isn't actually the psyllid insect itself. It's a sap-sucking insect, not dissimilar in size from an aphid that also feeds on phloem, but the psyllid transmits a virus, Libiribacter, and it's this bacteria transmits this bacteria, Libibacter, and the Libibacter is systemic. It grows throughout the plants, and particularly on potatoes. It'll absolutely cane the yield, make the plants look really sick. There's this thing called psyllid yellows, where the leaves, instead of being nice big flat leaves, they all crinkle up and turn yellow. So what we're going to do here with this trial is we've got Noha and Agria as our cultivars. Noha is considered to be highly susceptible to psyllid, or more correctly, probably more susceptible to Libiribacter. And what we're going to do is we've planted some cabbages, a range of cabbages, broccoli, that kind of stuff, and also some buckwheat as plants for attracting and hosting beneficial insects that will then go and hopefully attack the psyllid on the potatoes. The other thing we're going to do is cover the potatoes with mesh crop covers. Let's show you exactly what they look like. These are mesh crop covers. It's woven high density polyethylene, HDPE, and this is a physical barrier that we put over the crop, and that simply stops the psyllids getting to the potatoes in the first place. So what this will allow us to do is therefore compare how the potatoes have grown under the mesh versus outside, where they can be attacked by psyllids. Not a proper experiment because we haven't replicated it. I did a large amount of work, probably starting 15 years ago when I started at the Future Farming Centre in the BHU, actually looking at and working out, doing the research on mesh to understand if it could be used to control psyllids. And we also found it controlled potato blight. We suspect Alternaria blight. We're not convinced yet that we can control Phytophthora blight with it, main blight, but we also found it increased yields quite significantly. Indeed, potatoes seem to be really hampered by UV light, high UV light levels, which we have here in New Zealand. And by blocking UV light, which is what happens with this mesh, the white colour is due to the fact there's titanium dioxide in there as a sunscreen to protect the plastic. We found we can increase yield 30% by blocking UV light on potato crops. So it'll be a nice demonstration, and what's going to happen is Dr. Hendricks and Dr. Paul Horn will come down to this site. We'll bring students from the university and they will look for both psyllids and beneficial insects and be able to compare between those, the potatoes outside the mesh and the potatoes under the mesh. And so we will be continuing this as this project progresses.